Hi guys! So I wanted to make a video finally of what we talked about last week in Math 113. Um, so there are a couple things that I want to talk about. I'm just going to make a list for myself. So I want to talk about adding and subtracting mixed numbers and fractions, and then we talked about multiplication and partial products. Okay, so we started out last week, we had talked about borrowing when we were subtracting. And then we'd also talked about, I had sent you the link to the Khan Academy video about subtracting and adding mixed numbers. So let's just look at that for just a second because that was related to that. So let's say I have 3 1/3 minus 1 2/3. Okay, now clearly I have a bigger number here and I'm subtracting a smaller number. But when I actually look at the fraction parts, and sometimes it helps to kind of write these like this so you can see them lined up. The fraction part itself, I have a smaller fraction here and a larger fraction that I'm subtracting, even though the overall number on the top is larger. So this is kind of like if you have, $50, $56, let's say, and you owe $39. You have plenty of money to cover that, but you don't have enough ones, right? You could turn in a 10 for ones if you wanted to give exact change. So it's the same idea as that. So when we looked at this, when you looked at that video, we talked about how you'd have to borrow or unbundle, or exchange is another way sometimes it's worded. So just like with unbundling with regular whole numbers, whatever the place value is, that gives us 10 of the place value next to it. Well, here it's going to be a little bit different. If I take one of these whole numbers away, you've got now another whole. It's just in pieces, right? So if I had 3 wholes and 1/3 of another, so I had this whole thing, this whole thing, this whole thing, and 1/3 of another. What I'm essentially doing now is just taking another of these wholes and splitting it up into thirds. So I have 2 whole things, 3/3, and 1/3. Okay, so this is going to now become 2 4/3, which is not really a standard way of writing it because the fraction is more than 1, but in this case we've exchanged our whole for some more parts. Now the thing to remember here is that we're not adding 10, right? We're adding 3 in this case because I'm in thirds, and so 3/3 is how I would represent my whole. Notice that these have the same denominator also. Okay, we need to do that first before we could exchange. Now I can exchange. 4/3 minus 2/3, I can subtract, sorry, is 2/3, 2 minus 1 is 1. I can see this. If I want to take away 1 2/3, I could take away, here's 1, and then 2/3, I could take away this one and that one, right? And I have 1 2/3 left. So if I had something like this, if I had 5 3/10 minus 2 8/10. Okay, again, not enough on top, even though overall my top number is large enough. So when I borrow or unbundle this, I'm going to unbundle it into tenths. So now I would have 10 just because that's what my denominator is. So instead of 3/10, I would have 13/10. Okay. If we had one where the top number, the fraction part of the top number does not have the same denominator as the fraction part of the bottom, I'd want to change those first. Okay. But whatever your denominator is here, that's how many pieces you get when you unbundle, right? Because if I have a whole one, it's going to be 10/10, or 3/3, or if I'm looking at sevenths, 7/7. So that changes. It kind of goes along with adding and subtracting different bases, like we did with the time, person running around the lake, right? And when we added the minutes, we weren't looking for a group of 10, we were looking for a group of 60 to make a new whole. So it's the same idea here. We have to think about what makes a whole. So that was what we started out with last week. And then we moved into talking about those fractions a little bit. And so when we're adding and subtracting fractions that have the same denominator. Okay. Remember our definition of fractions. So if we have A over B, that's A parts, each of which is 1 over B of the whole. So if it were 3/5, we have 3 parts, each of those is 1/5 of the whole. This also tells us how many pieces it takes to make a whole. So when we add those together, let's see what this looks like. We have something split into fifths, so here's 1, 2, 3/5, and we have a whole, same size whole that's split into fifths, and I have 1/5. So all together I have 4 pieces. That's pretty easy to see. Okay. But sometimes people want to say, well, I have 4/10 now. And it's a little bit subtle to think about why that isn't the case. But a couple ways to think about it. Each of these pieces was 1/5 of what I'm calling the whole. This is my whole thing right here. So I have 1/5 of the whole, 2/5 of the whole, 3/5 of the whole, 4/5 of the whole. This is still my whole. So each of these pieces is 1/5 of that whole. Now, if it were going to be 4/10, that would mean this whole thing, this entire thing had become my whole because there are 10 pieces in it. We can't change what our whole is along the way. So we have to keep that whole the same. Also, if you think about, have these little fraction strips that we looked at in class that one day. I don't know how quickly I can get to fifths here. Here's a fifth. But if we add 4 of these, right, if we have 1 of these and 3 of these and we're adding them, they don't suddenly become tenths, which would be half the size. So your denominator is going to stay the same. Okay, now what happens if I have 2 things that I'm adding or subtracting that have different denominators? Well, we know we have to make a common denominator, but let's think about why. So 2/3 means that I have this whole, whatever it is. I always like to make my examples food, so I always think of a candy bar. But so, although in one of my other classes on Zoom, I was talking about ice cream the other day as an example, and someone's little 5-year-old came running up because he was excited we were talking about ice cream, so I felt a little bad. I shouldn't do that anymore. Okay, 2/3. So I have 2/3 here. And then I have the same whole that I'm starting out with. And I have 1/2 here. Okay, so I want to know how much I have all together. Maybe I finished 2/3 of a test, and then I finished a half of a test. I want to know how much I have all together. Okay, so if I get out my pieces here, I have 1/3 and 1/3. So there's my 2/3. And then I also have my half, which I kind of want to add on to it. The trouble is here that I don't really have a good name for how much this is, right? Because there's 2 different amounts here. I guess we'll put it down. 1/3 and 1/3 I know go together, but then when I add a half, I don't really know what to call 2/3 and a half. Okay, it doesn't really go together at all. So that's kind of the reason for needing common denominators, okay? Is that right here, these are different size pieces. So physically, when we're changing to common denominators, what we're doing is we're making it all the same size pieces so we can add them together. So obviously our denominator here, our common denominator, is going to be 6. So if we were to change this and say, okay, we have 4/6 and 3/6, then now I can add those, because if I have 4, can't really hold them up very well, so I'll just sort of have them here. If I have 4/6, so 1, 2, 3, 4, 6, that's my 2/3, and I have 3/6, well now it's easy to see that if I have 3 of the same size as these 4, I have 7 altogether of the same size. Whereas if I'm adding things of different sizes, I just don't have a good name for it or a good way to put those together. Okay. And how do we know common denominator? Well, I mean, mathematically we know the common denominator is the common multiple. Often the least common multiple, doesn't have to be. but it's a common multiple, meaning that 3 goes into 6 and 2 goes into 6. Okay, why is that important? Well, let's look at the pieces we had. So we had thirds before. Okay, I'm just looking at 1/3 right now. But 1/3 can be broken up into sixths. If I put these sixths on here, they're exactly 2/6 as part of my 1/3. You can see it exactly matches. Okay. If I have half, I can exactly put 3/6 on there. Exactly matches up. So sixths I can cut these exactly into 6. And obviously if I can cut 1/3 into 6, I can cut 2/3 into 6. Okay. What if I chose the wrong common denominator? What if I said, well, I'm going to make those into fourths. So these guys are my fourths. Well, I can take a half and I can say a half is exactly 2/4, and that exactly covers it, and that's great. Okay. However, when I go to my thirds, it does not exactly cover it. 1/4 is a little bit too small, and 2/4 is way too big. You can see that the orange ends about here. So I can't cut 1/3 into fourths. Okay, that's because 4 is not a common multiple of these two. 4 is a multiple of 2, but 4 is not a multiple of 3. So what we're physically doing when we find common denominators is that we cut things up a little bit more. So now we have the same size pieces. Okay, if each piece is 1/6 now of a whole, instead of being either 1/3 or 1/2, then those pieces have to be the same size. Okay. So that's kind of a little deeper dive into why we need common denominators. Physically, what's happening there. Okay, so I'm going to stop this video and then start up another one in just a second here. And we'll talk about multiplication, which we did on Wednesday. And we'll talk about sort of the definition of multiplication, as well as the regular multiplication algorithm and something called the partial products algorithm. Okay, I'll see you in just a minute.